BYP's video on the Drake TR3 with a new sideband filter. Notice that's filter singular. There are two sideband filters in the Drake TR3 and TR4. In both my rigs, both the 3 and the 4, the filter or filters were defective. It's a real problem to repair one because all the crystals are the same age. In the TR3 they're about 60 years old. They really all need to go because it's such a problem to take this thing apart, take the soup can apart and replace one and find the bad one. So a brand new filter was built with crystals I purchased from a big name high-tech supplier in Taiwan, and the performance is just off the charts. This video also covered the finish of this project, which has taken most of 4 years for rebuilding, modification, and extreme testing on the air. Because this has been a lot of work and a few significant modifications. It's all got to be tested very carefully before I even dream of doing this for someone else. So also cover some modifications that make the TR3 work a bit more like the TR4 and give it high-speed CW capabilities. This is the rig. It's been operating in a bake-in test, a drive level test and temperature test for the new carrier crystals. Crystals plural. What is this? A single filter and 2 carrier crystals? Yes, that's the answer for replacing 2 expensive, complicated sideband filters. The surprisingly inexpensive alternative is 1 filter and 2 carriers. That has a couple compromises. They're fairly minor. It works very well. And this has all come with the very unusual side effect of giving about another 15 to 20 dB of receiver gain. The signals now are just off the charts, and the noise has gone down considerably in the receiver. This is the rig, and by the way, part of the noise reduction is not in the filters. It's in something else. I'll explain that in a bit. This is a rig in receive with obviously the RF tune control turned way off. No S meter reading. And notice the AF gain. It's at normal volume. You might be able to hear a little noise from the computer PC fan running to the left here. It's making far more sound than this receiver. So at normal, this would be normal listening volume, maybe a hair more. So I'm going to put the phone over right in front of the speaker. You'll barely be able to hear the noise floor. That is mostly oscillator noise. That was tested by killing the oscillators and hearing nothing come out of the speaker. There's been a very significant reduction in internal noise due to a design compromise. I don't want to say defect. It is an insufficient design, but there's a design compromise in building this transceiver that resulted in exacerbating that noise. That's been eliminated. I'm going to turn the RF tune to tune on 40. That's with no antenna. Going to connect the antenna. And there's some, as expected, some van noise. Or as our friends in the CB trade call it, air noise. And we see S meter operation, and we hear someone splattering a bit. I'm going to tune onto the calibrate oscillator and watch the S meter. There's a peak in the S meter reading. It's 40 over S9. Before these modifications it was 20 over. There has been, as indicated on the meter, a 20 dB increase in received signal strength. Both as heard in the speaker and indicated on the meter. An absolutely phenomenal change. I can hear the hairs on an ant's legs with this rig. Go back to sideband and let's find the CW signal, and notice what you don't hear as I'm tuning down. And there's the digital slot at 76 on 40 meters. 50 over. But let's go down and pick up a CW signal. Close in on 40 meters these days, it's difficult to tell who's where and what the strength should be. When band conditions straighten out, it'll be a lot easier. But notice what you don't hear. You don't hear a bunch of noise. You hear another CW signal competing with this one, but that's normal. But notice how clean that is. Now we'll run up to the phone segment and try to find a phone transmitter that's not splattering all over you-know-what and back. There's a plague these days of solid-state radios being overdriven, splattering all over the band.
I'm still here. Thank you, Chief, and good morning to all. Anyone that I didn't say good morning to. Otis has a fantastic signal in here.
You may be able to hear the filament noise in his amplifier.
And I heard the commander in there.
A very low frequency rumble.
Otis and Essie, good morning to you.
Rather difficult to hear, especially in a solid-state rig. In a tube rig, it shows up.
I believe it was a 96th birthday.
It's not a regs violation. It's not a serious problem. It's just noticeable. Tube-type amplifiers will introduce some filament noise into the signal if they're using 60-cycle filaments. Here's a bit weaker signals.
I love greatness, but I can't have them anymore. But I always loved the taste of them.
Yeah. No, Frank, if Frank stops drinking his cran grape or whatever, Ocean Spray will go out of business.
Yeah, well, Robert drinks it every day, too.
I drink.
Well, these signals are, and I know you can't see this from this video, but the average signal levels here are 20 dB more than they used to be, and there's less noise. There was a problem in the design of the receive IF that caused what I think could be characterized as phase noise, and that's been eliminated. The transmit performance, I really can't show you in a video. The best way to judge that is to go to another station and listen. I can't be there and hear both. So I will tell you what the signal reports have been. On CW, I've gotten reports of perfect tone. No key clicks whatsoever had been eliminated, and there were some. But a ham about 5 miles from me reported on 40 meters that it sounded as if I was sitting in the room with him. It did not sound like it was coming across a radio transceiver. And I've said in his ham shack, and we've talked many times at length, so he knows what my voice sounds like. But absolutely flawless signal and audio. So this isn't so much fun. I'll pause the video and flip the rig up in its normal position, or the 90-degree position, which is on its side, high, and take the bottom cover off and show you the mods. And as I say, K8BYP returning with the extremely clean signal on the air. This is the original soup can sideband filter. Notice the cable taped up here and cable here. This is a special triax cable, 3 conductors, not common anymore. This thing's difficult to get out and get apart. Takes up a tremendous amount of space that I want to open up for other switching and for putting in RIT, which would be an extremely useful addition on AM. So this is going to come out. But the sideband filter singular is now here and here. There's been a significant design improvement by splitting the filter in two and eliminating this fancy triax cable. And there's some other things going on there I'm not going to talk about. I'm going to keep them secret because they may be valuable. There were some improvements made in switching to eliminate the need to change the mode switch for AM and CW. Back in the day, relays were huge. A relay back then was about the size of this transformer, which is now about the size of the end of that pin. And you can see one of them here. That's a SIP reed relay. Extremely low parasitic capacitance, cheap, small, ideal. But this is a board that I designed and built with relay switching to make this rig a full CW AM and sideband transceiver, and also to eliminate a rather annoying problem of carrier leakage. This rig leaks carrier all over the place. Align it, it'll go a bit out of alignment and go back to carrier leakage. I've never been successful in getting rid of it. The manual says minimize it. Well, good luck. So what I did was muted the carrier in receive, and that's made a big difference in receive performance. It also eliminates some spurious carrier on CW key up, which could be heard under close end band conditions on 40. A few tens or hundreds of milliwatts can be heard as stayed away. So that's gone. Back here is the carrier oscillator board that includes the carrier shift for CW and AM. With the new filters, it's probably not needed in AM. I may do away with that. But in the old filter, it was necessary to jump the carrier up from below 9 megahertz to somewhere around 500 cycles above, because the oscillator, the carrier oscillator, was centered between the filters and it was too low to make the passband filter. That also resulted in tinny, poor, high-pitched audio on sideband. With these modifications, I can basically run the carrier right up against the bottom of the filter, and it passes my low-frequency voice very well. So that is a massive improvement in this rig. But in order to use one filter, the carrier must be, as I'm saying, jumped from below the filter for, let's say, upper sideband to above the filter for lower sideband. And in this rig, when bands are changed, that flips. Drake users will know that. If you're not familiar with it, you'll figure it out. It's because of how the mixing works. But this board contains two carrier crystals and the carrier shifting circuitry for CW and AM. Both of these are on proto boards, which I'll probably leave that way because they're cheap and easy to get. And with all this panic over this phony pandemic, I don't want to trust a circuit board house shipping boards when I need them. And these circuits are fairly simple. They can be built on proto board. But I've left a little bit of spare area here for some more circuitry. But very small. This board is basically a bit smaller than a credit card, and this one about half that size. Fortunately, because with all the empty space in here, there's not much room for putting anything of any size. But another thing that this filter design has done has shortened the cables from here to here and from here to here, strung out all over the chassis, picking up noise, to just 6 inches or so, and very short lead wires for connecting to the transformers. This filter is also tunable. There's a variable capacitor here that will change the passband response along with the adjustment of the filters. It's possible to broaden this filter out to almost 3 kc if you want. I don't like it. There's nothing in my voice that needs over a kilohertz or so. I sure don't need 3. And that just improves the gain bandwidth product. For the CW buff, there's the cable that goes to the keying unit that I designed to go with the 857, to use 857 as a high-speed memory keyer, and has a breakout delay control on a short cable that can be mounted up under here without drilling a hole through the front of the radio, which I've really avoided doing.